Hello everyone, welcome to Coders Camp. We are at 31st day of October LeetCode challenge and the problem we are going to cover today is flatten a multi-level doubly linked list. So we have seen similar problems already, like flatten a binary tree to a linked list, flatten iterator to a linked list, and etc. And this is one of a kind. And so the input given here is a doubly linked list with multi-level, including child nodes and stuff. And we have to flatten the given linked list without any childs and return as a single level doubly linked list. So let's understand this with an example. So here is a given example multi-level doubly linked list. They have designed each node to have 3 pointers. Since it is a doubly linked list, it will have a next pointer, a previous pointer, and since it has a multi-level, then it should have a child pointer to connect it to the next level of nodes. So any node can have child nodes, and from the child node, it can have another set of current next nodes. So our job is to connect all the nodes to a single level doubly linked list, which means there should not be child nodes at all. Instead of child nodes, we have to make everything in a single flattened way. So to do that, the idea is to do that is, so wherever we find a child node, we have to connect the next of the current node to head or the next of the child node, and the previous of the child node would be connected to value of the previous node, so that this child will be removed and actual connection will be given as if it is a continuous node. The same happens to 8 and 11. So 8's next will be connected to 11 and 11's previous will be connected to 8, and the child will be set to null, because since they are in the same level, we should remove the child to make it in a single level. So we know the one-way connection. How does the other way connection happen? So the neighboring nodes will be same, connected to 7, 8, 9 and 10, but then 10's next will be connected to 3's next, which is 4, so that it happened to have like a single level linked list which will be connected to, after 10 it will be connected to 4. So from 4 it will be again continue to 5 and 6 because they don't have any child under 4, 5 or 6. Same happens to 12. So once 11 connected to 8, 12 is the next node to 11, so it continue in a series. Then 12 will be connected to what is next to 8. So what is next to 8 is 9. So 12's next will be connected to 9, and 12's previous will be still the same with 11, and 9's next will continue to connect to 10. But then the connection between 8 and 9 will be removed. The same way connection between 3 and 4 will be removed. So it will become 1, 2, 3 and then 7 and then 8. From 8 it has another level, so it goes to 11, 12. So 12 connects back to 9. So then comes 9. After 9 it is 10. 10 connects back to 4 because we connected 3 to 7, and end of what is in this level will be connected to the next node in the 3. So we'll have 4 after 10 and then 5 and then 6. So this is the idea of how we are going to make the multi-level into single level. So how do we approach it programmatically? So here the idea is to use a 2-pointer technique like we use a pointers in any linked list problem. So we have a pointer P that gonna point at the head of the linked list, and we will introduce a pointer temp if needed, because there are 3 kind of cases. That is, there will be no child node at all in the given input node, which means the list is already single level, so we have to simply iterate it and then return the head of the linked list. So this is one case. The other case could be having child nodes to make it multi-level. So in this case, whenever we find a child node, we are going to introduce a pointer temp to iterate and find its end. So now let's start by iterating. So first P is at the first level. We are going to check if the next of P is not null, then we are going to iterate it to the next node. So it is not P, it is having a node. So let's iterate it to P. And again we are checking it is having a child or not. No, it is not having a child. Previous node also not having a child. So let's move to the next node. So next node is 3. Now P is at 3. 3 is having a child node. So in this case, we have to connect its child level to the next node to P, which is nothing but P dot next. So P dot next is 4 here. So what are we going to do is, we are going to connect P to temp and end of temp to P dot next. So first, instead of connecting P and temp, we are going to connect end of temp to P dot next. There is a reason, I'll let you know why. First, let's start iterating till we face a null value. So now our temp iterates through 8, 9, 10 and finally faces a null. So now our temp is here. It's time to connect temp with P dot next, because that is where our connection has to link. So we are going to connect next 10 dot next to 4. And since it is a doubly linked list, 4's previous must be connected to temp. So yes, a connection is established between temp and P dot next. So now it's time to connect P with temp. So P's next will be connected to 7 and 7's previous will be connected to 3. So now the connection has been established between P and 3 and 7 and 10 and 4. So it's time to remove the old connections. So 3 and 4 should not have connections. Also, we have to set the child connection between 3 and 7 to null, because since we made it single level, there should not be a child node. So we have established a connection. In this case, now our P is at 3. It's time to iterate it to the next node. The next node is nothing but 7, which is newly connected to the single level. So now our P is at 7. 7, we are checking whether 7 is having a child. No, 7 is not having a child. So iterate our P to the next element 8. So now it is checking again P is there or not. Yes, P is there. And sorry, child is there or not. So child is there. So since there is a child, we are going to introduce our temp pointer to its child. So the same procedure is going to be followed. We are going to iterate temp till it faces a null. So 12's next is null. So we are going to make a connection with P dot next. So our P dot next is 9 now, because P is at 8. So we are going to connect 12 dot next to 9 and 9 dot previous to 12. Same way 8 dot next to 11 and 11 dot previous to 8. So once this is done, we have to erase the existing connections between 8 and 9 and the child connection between 8 and 11. So once this is done, our P iterates to 11 and then 12. They both have no child, and then after 12 it is 9, because we already made the connection and made it single level. So it is going to 9, 9 it also not having child, 10 also not having child. So since the connection is already made between 10 and 4, the next pointer P moves to 4 and checks whether there is a connection between a child node between 4. No. There is a child node between 5. No. And iterates back to 6. Now our pointer is at 6 and checks whether it is having a child node. No. So we have come to the end of the iteration and the value is null and no more child nodes to iterate. So our linked list has made its connection through and came towards the end of the linked list. So it's time that our linked list has flattened. So we have to return the head of the linked list since we have made the connections internally. So yes, this is it. And this is going to run big O of n time complexity, where n is the total number of nodes in the given input list. So yes, hope I made it clear. So let's go to the code now. So yes, as I said, let's cover the basic conditions, that if our head is null, then return head. So let's declare our pointer P towards the head of the linked list. And we are checking if P is not equal to null. So this loop goes until we go to the end of the linked list. So now we are going to check for each pointer P points at a node whether a child exists or not. So this is the first case I said. If there is no child at all, then we are simply going to traverse until we meet a child and travel towards the end of the linked list. So if child is equal to null, then we simply going to move our pointer ahead. So if not, which means we found a child. So in this case, we have to introduce a temporary node. temporary pointer which points at the child of our current P. So as I said, we are going to travel our temp until it meets the end of that particular level list. So since it reached the null, it's time to connect temp.next to p.next. So because we kept our pointer p towards the previous node. So as I said, we are going to connect temp.next is equal to p.next. And we are also going to check if p.next is not is equal to null, because in some case our p, the last node in our list, might have child. So we have to connect the last node of temp to null. So if not, if there exists extra node next to p, then only we have to connect it to its previous. So we are going to check if p.next is not equal to null, then we have to connect its previous to temp dot, sorry, only temp. So yes, this is it. Now we have established connection between the nodes. Now it's time to connect and disconnect the existing connections. So p dot next is equal to p dot child, and once we connected p dot next to p dot child, its previous is going to be p, and we have to remove the connection between the child pointer of the current pointer. So p dot child is equal to null. So yes, this is it. Once the loop is completed, we would have flattened our list already. So we are going to return the head of our linked list. So you can approach this problem recursively as well, but this I find very straightforward and easy to approach. So yes, our solution has been accepted. So let's submit and try. Yes, we have completed today's challenge and it runs in 0 millisecond and 100% fast solution out of all the solutions submitted. So thanks for watching the video. Hope you like this video. If you like this video, hit like, subscribe and let me know in comments. Thank you.